Hey guys, welcome back to Ox Tools. I'm Tom. So this is another episode of Meatloaf, and we've got some interesting stuff to take a look at. Got some viewer appreciation gifts. We've got a tool demonstration that we're going to look at, which is kind of cool. We got a little inspection job from a viewer that we're going to take a look at, and probably a couple other things. So I'm already suited up. Let's buzz around the shop and go take a look at some of this stuff. Okay, so you guys are witnessing the only guy in Benicia that probably has two planimeters. Now, a viewer sent me one of these, and let's see, I think it was this one first. And this comes from Remy Simmerl, and he's up in Canada. He sent me this one. I guess it was in his dad's toolbox or something like that. And I showed this, I don't know, a couple weeks ago or whatever. And I mentioned on camera that it was missing the little magnifier or little reticle thing here. It's also missing a couple things here, but those are kind of minor things. You know, most of it's here. Anyway, he says, "Oh, hey, I couldn't find that, but instead, I'm going to send you another one." So I think he went on eBay, and let's put these side by side here. He went on eBay and found a complete one, and this one's actually pristine here, and it has the instructions and oh yeah, there's a note from him. I forgot it was in here. It has all the goodies with it. So what I thought, and what it exposed to me as I was playing around with these is this one's actually got some problems. The zero setting thing doesn't work correctly, and it doesn't count correctly either. So I think this one's injured somehow. So we're just gonna set this one aside, and we're gonna bring this one out and do a demo on it. So, and I mentioned before, and I'll mention again, these are for measuring areas on maps or areas under the curve on graphs. Or plots or things like that, or irregular, oddly shaped areas, stuff like that. It's a very clever, it's basically a mechanical integrator is what it is. And it's a very cool concept. And the guy that came up with this is long dead, but it's extremely clever. So let me get it set up. And then we'll measure the area of something, and just for fun, and see how it works. So anyway, there's the missing piece there, and then it's got another little. Oh, that's probably for setting the scale there. But it's got all the. This one's got all the goodies with it, so it's not missing anything. And this is actually for checking the area. You can go around this, and this is a 100 square centimeters here, so pretty cool. So let me get it set up, and then we'll do a little we'll do a little dance with this and see how it works. So okay, so we got it set up, and you can see the different bits. This has got a little point here that sticks in the thing, and then it's got a little ball joint that fits into a socket here. So what we're going to do is we're just going to measure something that's real easy to measure here, and we'll measure this post-it note, okay? And so the way you set it up is you get this, you know, kind of 90 degrees here. It's tolerant to a little bit of, oops, what's going on there? Huh? I didn't know that turned, huh? Okay, so we'll set that at 90 degrees. We're going to stick this in, so that's firm, and I'm going to put the reticle on the corner there, and I'll zero the counter. And then what I'm going to do is I'm just going to, let me zero it again, carefully trace around the perimeter of this. And the thing's counting. It's a little hard for you probably to see. Maybe I'll zoom in. We'll see how it goes. And I'm just going to cruise around this perimeter like so. Okay, and I went clockwise because that's the way the counter works. Okay, so my display says 9. All right, now I've got it set for square inches. So, and this happens to be 3 by 3, which would be 9 square inches. So now let's double check that by doing another. Do another one here. Do this larger one, and I don't know what size that is. So let's go ahead and zero that. You know, I think it's 3 by 5, but let's go ahead and do that. Okay, I'm zeroed clockwise. I'm holding this paper down so that it can roll up on it. So okay. And so we had 10 plus 5, 15. Okay, so that would mean this is 3 by 5 inches, correct? Okay, so now that's all fine and dandy, but you know, bottom line is that you can measure something on a graph that looks like that, right? So what we do is what we care about is maybe this area under this curve here. So what we can do is we set our starting point there. All right, and then we can go around this kooky curve here. Okay, and that is, what is that? 2.4 square, is that right? Am I reading that right? 1.56 square inches. Let's see, does that make any sense? 1 by 1, yeah. I could buy that. Okay, just looking at this, what's 1 by 1 and another half of that, something like that. So you can measure some areas like this that normally you would be integrating. You'd be dividing that up into little slices and integrating that curve. So it's a mechanical integrator is what it is. So it's useful for those kinds of things. Or if you have let's say that's a lake on a map and you want to know what's the area of that lake, right? Well, there's different scales. You can set these scales differently so that depending on what the map scale is, you can read directly into area for that map scale. So pretty cool stuff. So like I said, this is a very clever little device, and I've always wanted to play with one. I've never had the opportunity. Of course, I asked my dad, I go, hey, have you ever played with a planimeter? He goes, as a matter of fact, I have. So my dad does analytical chemistry. Well, they get these weird plots of these different constituents when they do analysis, right? So they have these weird peaks that kind of look similar to this, and sometimes the computer has a hard time measuring the area of that, believe it or not. So I said, yeah, don't you use a computer for that? And he goes, no, sometimes the planimeter works better. So it's like, okay. Anyway, Remy, thank you very much. That's cool. It's a fun toy, and it's going to go in the instrument drawer, and I'll pull it out and if I have a weird area measuring job. So thank you very much. Okay, so here's this chuck I got, and this is it's actually a Pratt and Burnett, and but this is their, I don't know what you'd call it exactly. It's their value line. Okay, so this is distributed by Pratt and Burnett, and they market it under Atlas Work Holding, which is a company that makes chucks and fixtures as well. But this is the chuck I picked out, and for the autometric, I wanted a 4-jaw setup on it too. And so this is what I got, and there you can see the Atlas on there. I'm real happy with this, actually. Now, the story here is this came from one of my sponsors, one of my generous sponsors, and that's KBC Tools. And KBC Tools has been around for, I don't know, 50 years, since 1965. And it's KBC Tools, and this is one of their flyers here. And they have a close association with Noga and a lot of the machine tool builders. So they got some cool stuff. Anyway, I have a friend there. Her name's Paula Bass. She's the president. And she sponsors the show a little bit, which is great, which is wonderful. Allows me to try out some of these things that you might wonder about. So the bottom line here is this value brand of Pratt & Burnett looks really good, and came with a chuck key. And now this is a 6-inch chuck, a little over 6 inch, about 160 millimeters, something like that. And it has it's a front mount chuck, and you can see the back. It's got a little recess. And this is what I wanted for the autometric. I wanted to be able to mount it from the front. Now we have to make an adapter to mount this to the machine, but that's another video. I just wanted to show the chuck here. And it even came with fasteners, which I thought was wonderful, right? Because now I don't have to scrounge these up. These appear to be metric, so but no problem. And we'll get rid of that. We don't want that. So we have to make a little adapter to get this on the machine. So, but if folks are looking for a chuck line that's decent quality, and this is made in America, Kalamazoo, Michigan is where it comes from, and it looks pretty good. I'm pretty happy with it. It runs smooth. The jaws look really nice. It's not a cheesy import, or let me rephrase that, a low quality import. So this was, I want to say, a little over 200 bucks, I think. I don't know if I have the paperwork here. I don't think it's going to say on the packing list here. Atlas value line, 6-inch, 4-jaw independent chuck. Yeah, no, it doesn't really have my the price on it. But anyway, Paula, thank you very much. This is great. We're going to mount this up on the autometric, and guys, if you're looking for chucks and fixtures and tooling, go check out KBC Tools. They're having a 50th anniversary, and they have some different items than a lot of the other tool peddlers have. So, is this it right here? Yeah, okay, so this is, here's a good example right here. So this is a 3-jaw here, and this is their value line, I guess they call it. So, let me see, I'm reading upside down here. So this is a plain back, 3-jaw, master top jaws, 6-inch, is regular price $230, sale price $195.50. So, and they have this shipping deal too. They got this kind of flat rate shipping thing going on too. So I think you can get it shipped for about 10 bucks, which is kind of nice too. Takes a little longer, but it's cheap shipping. So, you know, when you're buying heavy items like that, it's kind of nice. So anyway, check them out, and I think you can look at this flyer online. www.kbctools.com, and tell them I sent you by. So let's design a mount for this, and let's get cracking. Okay, so as long as we're talking about sponsors today, here's another item that came from one of my sponsors, and the Noga Corporation that makes indicator arms and deburring tools and many other items. They sponsor some of the YouTube creators around, and a box showed up the other day, and it had one of these the big boy or the Atom model indicator holders. Now this is a serious indicator holder here. It's, you know, it's 8 pounds or something like that. It's pretty hefty. It's made out of steel. It's very high quality, and it's got this massive magnet. I think the magnet's good for 175 pounds. Now, I have one of these at work, and we use it a little differently than probably Noga kind of intended. Well, I don't know. I don't know what Noga's intent is. I mean, obviously they give you an indicator mount, but you don't need to limit yourself to that kind of thinking. So we're actually going to take this off, and we're going to put something else on there. Oh, and by the way, this has always bothered me a little bit here. So they must have bought 2.5 million of these lock washers, but these lock washers are actually large for this fitting here. So I'm not sure what the thought behind that is, but it doesn't fit the fastener very well. It tends to push off a little bit to the side, but I think they're trying to match this diameter. That's all I can think of. Anyway, it doesn't really matter. We're not going to use that. So I'm going to show you how we use this, and a real handy use for a large indicator holder like this, and to make it real functional for something that comes up in the shop once in a while. So let's go check that out. I'll put it together, get it set up, and then I'll bring the camera over there. Okay, so this is how one use for this big heavy-duty arm here. We mount at work. We have to cut a lot of G10 epoxy laminate, and it's pretty stinky, and the dust is kind of noxious. So what we like to do is use a shop vac and get it up real close to the work where the action is there, and then lock this down, turn the shop vac up on, and do your business, and it just sucks all that crud right into the shop vac, and it doesn't go spraying all over the room and getting all in the machine. So now you see here I got it mounted. Let's see, I hope you can see that. Let me move that out of the way a little bit. I got it upside down on this little dovetail here, and this magnet has more than enough oomph to lock it upside down and be stable, So and then you can just pop it off, and get it out of your way. But in reality, in fact, this thing's heavy to hold up here to put on there. If you do these kinds of operations regularly, you can just pull it out of the way and you can just kind of leave it. It doesn't interfere with operations if this is something that you do normally. Now this will even work. You can pick up metal chips too. It doesn't have to be a dusty thing, and you can see I can position around here real easily and just lock it and get it right in place, and then I can still pop these off and put different attachments on. So and this is just I think they're called Stauffer clamps. McMaster sells these in a bunch of different diameters, and I just mounted it to the M6 that's in the Noga. So anyway, and then you can take this over to the grinder. You can put on the surface grinder or the bench grinder, belt sander, wherever you're making dust or crud that you don't want floating around the shop. And usually there's a ferrous surface or a magnetic surface that you can hook these to. So anyway, that's how I'm going to use this thing. And Avi, thank you very much for the nice gift. This is great. Now I have one of these at home. I have one at work, but I don't have one at home. And I'm looking good here. Thank you, my friend, and thank the Noga Corporation for their generous sponsorship. So thanks, guys. Okay, so this next one's actually kind of interesting here. This comes to us from Gary Weldeley, and he's in Southern California, and he wanted to make one of these R8 little Noga adapters here, like this. And I don't know if you remember, but we wanted to set a precision angle for this so that it would fit the spindle real good. Okay. So he was, trying to come up with a way that he could actually set this angle on his lathe and cut that taper and do a nice job of it, right? So, he looked at what tools he had, and he came up with kind of a unique method that's worth sharing. So he and I have been talking on email a little bit, and he decided that it would be cool we both decided it would be cool to check out his template. So the angle that he was going for was 8 degrees 25 minutes and 30 seconds, which is the half angle of that particular cone there, okay? So what did he have available to him? So he went online and he went to this is Rudy Scarab's triangle calculator, which is pretty good, and he's got a little layout of how he did this here, which is pretty clever, and it's actually an interesting way to do it because he's increasing his apparent leverage with the angle, and I'll explain that a little bit more in a minute here. So let's just kind of recreate what he did here. So he had a carpenter square like so, okay, and this is 24 inches. Let's set this aside. Actually, you know what? I'm gonna leave that here. 24 inches from here to here, and then what he did was he put a straight edge across, okay, like so. And according to this angle calculator here, that if he's at 24 inches there, he needs to be at 3.554 off of this edge. So I'm just going to set it kind of, you know, roughly there, okay? So this angle here, and maybe we can see, if we lay that on there, that looks parallel with that, okay? So what he did was he used that to set up his angle. And I have some pictures that he sent me too, and if I have room on the video, then I'll plug some of those pictures in too, so you can kind of see how he set that up. And these holes were so that he could clamp it, so which was a nice addition. Now, what he asked me to do is inspect this angle and just see how he did with this method here. Now, this is what I'm talking about. You know, he's only doing this, you know, over 4 inches roughly here, okay, and a little more than that, 5 inches, okay. So, and what he really cares about is only around an inch, okay. So he's got excellent leverage here with this setup here. So, you know, he can position this end pretty accurately because he's got a you know, kind of a sharp corner there to work with. And then this end here he can set with some calipers, and let's just say that maybe you can resolve 0.010 of an inch there, okay. So that gives you about, I don't know, 2400 to 1, you know, 1 part in 2400 kind of leverage on this angle here. So it's reasonably sensitive. Is that the right word? No, sensitive isn't quite the right word. Tolerant, okay. So you know, we're really talking about 1 part in 2400 here. So what we'll do is we'll go over on the surface plate here, and we'll set this angle up as a precision angle, and then we'll sweep the top of his template and see how he did. And now remember, he only needs an inch of this, okay? So you know, he's got, you could also say it's 1 part in 24 what he really needs here, okay? So let's go over to the surface plate and get this set up on the surface plate, and we'll run an indicator down there and see how he did. So this is kind of fun. This is cool stuff. Okay, so we're over here on the surface plate, and we've got our half angle set up, and these are Starrett Weber angle gauge blocks. So we got 5 degree, 3 degree, 20 minutes, 5 minutes, and then 30 seconds. So that's 8 degrees, 25 minutes, 30 seconds. So, which should put this surface here parallel with the reference plane here. So let's go ahead and sweep it. You know, and it's going to be a little hard to see the indicator face, but I'll try to shade it when I sweep it. Let's get a good 0 here. Oops. It's hard to creep up on a. All right. well, it's a tenth over, something like that. Okay, so let's just whip our way down here. So over our 5-inch length here, about, can you see that? It's about 2/1000. Let's go back. Let's check our index. Looks like it's got some issues side to side, but we'll just go for the middle here. So we'll just go down the center line, and that'll be our reference. It looks like compared to you know, I have it clamped up against this angle plate, so that's introducing a tip to that or something. I don't know. Anyway, so we're zeroed up nicely. Okay, probably see that. All right, let's whip down. And we're in the middle down here, and I got about 2/1000 over the length of that, which is pretty damn good for setting it up with a carpenter square and a straight edge. Okay, now remember what I said about, you know, over 1 inch, right? Let's just approximate down about an inch. Call that an inch. That's 5/10. Okay, so over that short distance there, he's 0.5 off of the true angle. Now you could argue that this tip in here introduces a little bit more, but I'm still impressed with that method. Like I said, it has a high leverage ratio against the angle. So anyway, Gary, nice job on your little template here. I'll send it back to you, and I'd hang on to this because it's pretty good. It's about 2/1000 off over the 5-inch, and you know, somebody could probably calculate that and tell you what the actual angle is based on that. I'm not going to do it. That's easy enough for somebody else to do. Anyway, 2 thumbs up. That's pretty cool. So there's a method for setting angles using a larger scale setup. Okay, so this came from a guy named Mark McMahon out of Nashville, Tennessee, and he calls these tentaclips. And the idea is that it's a bottle opener for one. Okay, I'm not going to open this, but there's how the bottle opener part works. And yes, this is Blenheim ginger ale. If you guys haven't tried this, this will clear your sinuses. Let's just say that. Good stuff. Anyway, Mark sent me this. He's an engineer in Nashville, and he makes these and gives them away as little gifts and stuff. And it's laser cut, nicely laser cut out of 3/16 thick stainless steel. And it's got a little hex thing here, so you can use it like a wrench. I guess there's a couple of sizes along there, and then you can hang your keys on it, so it's like a little key ring thing. So pretty cool. So my only comment, Mark, if you're watching here, is you need more time in the tumbler. Okay, I would leave these in there for a couple of days. Actually, you're not going to hurt any of these edges in the tumbler, and it could just use a little more time in the tumbler. But it's a nice shape. Reminds me of some kind of octopus or something like that. It's pretty neat that way. So got some little bumps on here to help retain it in your pocket, and so the fabric goes in between there, which is kind of neat. So Mark, thank you very much. This is great, and keep up the great work, and thanks for the cool gift. Thank you. Okay, so this next one comes to us from Mark Godwin, and I think this is my first package from Asia. So Mark has a welding and fabrication business in Japan, Ottawa City, and he does, well, he's called it Monster Fabrication and Mechanical Services. So he works on equipment there, and his little guy here, his little monster's got some little TIG welder and a wrench and stuff. So I have to say, this is my first package from Japan, or from Asia, anywhere in Asia, and I appreciate it. That's wonderful. And these are decals, so he sent me a bunch of decals, which is cool. So we'll make sure that we send some Ox Tools stickers out to you in Ottawa City. So Mark, thank you very much. That's cool. I need to get a little package from Japan. So thank you. Okay, so this next one is pretty cool. This comes to us from Lee Rayburn, and he's in Chapmanville, West Virginia, and he likes to walk in the woods and find these whitetail antler sheds, and he makes. So this is a honing steel here, so you can hone your knife a little bit and touch it up. Oh yeah, and touch it up a little bit. So this is it's a commercial steel that he's inserted into a. Oh, I didn't even notice that he's got his initials in there. That's cool. And it looks like he polishes them up. And then the extra piece here. Apparently, dogs really enjoy gnawing on this stuff. So he sent a little piece for Ernie, the shop dog. So and his dogs help him find these sheds in the woods. So. Anyway, Lee, thank you very much. This is cool. Nothing like a handmade gift, I always say, and that's real nice. This actually fits pretty good in the hand, and it's got a large diameter here, so when the knife comes down, it doesn't you're shielded a little bit. So nicely thought out. So thank you. Appreciate that very much.